Hello everyone, my name is Azimkhon. I want to present our paper named RLSS, a deep reinforcement learning algorithm for sequential scene generation. This work is done in collaboration with Peter Wonka and Dominik Michels. Deep generative models are mostly image-based and therefore use pixel-level reasoning, which can be poorly adapted when handling various domain-based constraints in scene synthesis problems. Deep generative models plus constraint check at each step leads to an increase in the synthesis time. Optimization-based methods such as Markov chains, Monte Carlo requires thousands of iterations to synthesize one plausible scene and also shows low diversity. In contrast to many other generative approaches based on neural networks, our method learns directly from the constraints of the domain rather than learning from the dataset. This is in particular useful as collecting high-quality data is not an easy task, and also existing datasets might not be always available. Also, it handles large number of actions easily. Moreover, it allows for incorporating domain knowledge, in particular hard constraints and predefined design objectives, working well with structured data. In this regard, hard constraints are, as usual, a set of constraints that should always be satisfied when synthesizing a scene. Usually these are coming from the problem domain, and violating these constraints makes it impossible to continue the generation process. In contrast, design objectives shape the overall appearance of the generated scene. They can be understood as a broad definition of the scene we would like to synthesize. Only scenes fulfilling the predefined design objectives can be considered as valid examples for high-quality scenes. We demonstrate the capability of our method by considering two problems: indoor planning as well as the generation of level for Angry Birds. In indoor planning, given different room boundaries, our method is able to generate a high variety of plausible scenes. Our method starts generating a new scene from an emptied room by placing objects one by one. What are the hard constraints in this context? The generated scene should be collision-free, which means that every object shouldn't collide with other objects or room boundaries. Moreover, it should be possible for a human to move within the room. Hence, no object should block another object to keep them accessible. What are the predefined design goals? The room should contain all necessary objects for this type of the room. For example, a bed is required in the bedroom. These results are generated with deep convolutional priors for indoor scene synthesis method. These results are generated with our new RLSS method. Our method can effectively capture hard constraints in contrast to previous methods. The method places objects iteratively in the virtual scene. For each step, the agent chooses which object to place and where to put. A high reward is assigned if desired properties can be observed after the previous action. In contrast, the violation of constraints is penalized. The methodology is based on some modifications we did upon the proximal policy optimization algorithm. These modifications include action space separation, reducing the number of actions in order to learn efficiently. Reward designing based on greedy search allows to incorporate domain knowledge in generation process. Balancing between variety and achieving predefined design goals. We introduce tau parameter to control diversity of the generated results. This is proposed network architecture. Here in the first table we compare our method with state-of-the-art methods by the number of criteria. The second table shows the results of the perceptual study, as it can be seen from the data that our method shows the best results for almost all comparisons. Here we see different examples for bedrooms, for living rooms, and for offices. As an additional benchmark from another context, we apply our RLSS method to generate levels for the physics-based game Angry Birds, aiming for a wide variety of stable game levels. That's all. Thank you for your interest for our work and watching this video.